today's lesson, we're going to cover the volume of prisms and cylinders. So just keep in mind what we worked on yesterday with classifying our different solids. We're just going to be working with prisms and cylinders, like I said. So the first type is your rectangular prisms, or we can call it cubes if our bases are squares. But for this one, our volume formula is just to take the length times the width times the height. So they're going to give you all three of those dimensions. Again, our base shape is this bottom rectangle. If you think back to what we were doing yesterday. There's two bases to a prism, so we also have a base up here. And then our height, remember, must connect our two bases together. So keep that in mind, your height is always connecting your bases to each other. So I would, on this one, I would take the length times the width. And the order of those doesn't matter, again, because it's multiplication. And our volume would be 3,662 centimeters cubed. Now, volume is a cube unit because we are multiplying three dimensions together. The length is one, the width is one, and the height is one. So those are our three dimensions that we are multiplying together. If you look further down on page number 4, we start into other types of prisms. So our base shape is what defines our prism, like we talked about yesterday. Our base shape could be a triangle, a trapezoid, a parallelogram, a rectangle, and that would determine the type of prism we have. Now, for rectangular prisms or cubes, it's always length times width times height. But for our other prisms, it becomes big B times H. Now, big B is going to be the area of the base. I'm going to write that down. Make note of that. Big B is area of your base. So your base shape determines what your big B is going to be. And then again, yes, you're always multiplying by the height. Your height must connect your two bases together. So our height is this segment because it's connecting this base triangle to this base triangle. So if I look at number 4, my base shape is a triangle. So I'm dealing with a triangular prism. So if I'm thinking of big B, well, big B for a triangle is 1/2 base times height, right, to get my area of a triangle. So I can run that separately, or I can run that at the same time as the volume. That's really just up to you. But if I'm looking at this triangle, well, remember back when we were just doing straight area, our right angle tells us what two sides we need. So sitting on my right angle, well, that's on this segment, and then my height would intersect the right angle. So my height of just the triangle is 7.3. My base of the triangle, well, that green segment is white, but if I look behind it, this 12 can go up. Because the rectangle opposite sides are congruent. And then we have our 1/2. So big B is going to be equal to 43.8. So to go from that to volume, all we have to do is we have to take it and multiply it by the overall height of the prism. So I need to multiply it by the height of what's connecting my two triangles together. If I find my other triangle, it is back here. So the segment that's going to connect my two triangles to each other is going to be right here. Notice that that's connecting the front point to the back point. And that will be my height, so I'm multiplying this by 5. We get an overall volume of 218. And again, my units are now cubed. Because I'm multiplying three dimensions together. And I say where? Well, I multiply by a height, and then up top I multiply by base and height. Okay, let's look at number 6. So on number 6, my base shape is going to be a trapezoid. So in a prism, to know your base shape, look for the shape that's not a rectangle. And that would be your indication of attribution. So I see a trapezoid here, so that obviously is my base shape. Again, to start out, we would want to find big B. Big B is a trapezoid. Your area of the trapezoid is 1/2 height, base 1 plus base 2. Okay, well, if I'm looking at my trapezoid, I've got a right angle right here. Remember, it sits on your base, and there's another one up above it, and then my height connects my right angle. So my height of my trapezoid is 17.9. Of the trapezoid prism. This 36 would bump up, so one of my bases is 36, the other one is 14. So my area of my base is going to be 447. Okay, so again, to go from from area to volume, we just need to multiply by the height. So if I find my other trapezoid is back on it, your bases should always be parallel to each other. So one's in the front, one has to be in the back. The segment connecting. So pick two corners that you want to focus on, and I'm going to focus on front, right, front, right. And we want to connect those two together to find the height of it. And we might say, that's blank. But maybe let's change our mind. Let's look at the back ones. Back ones. And there's that segment connecting them together. So my overall height is going to be 25. So I'm going to take that 447.5 and multiply it by the height of the prism. And we will get 11,187.5 millimeters atoms cubed. Again, so we have multiple dimensions. We have height in the area, we have base in the area, and then height in on the wall. All right. Go ahead and turn to page 7, and we'll look at number 7. So what I see here is I have a base shape that is going to be a triangle. Again, it's the only shape that's not a rectangle. It's not a base shape. We're going to do triangles. So if I'm looking at my one triangle, my right angle is right here. And as far as my segment is concerned, it's sitting on this one, and this vertical one is what intersects my right angle. So those are the two I would need for base and height of that area. Well, I can flip this 28 over, but I don't have the base. So we gotta run Pythagorean theorem. So to find this base shape, I'm gonna do a squared plus b squared equals c squared plus squared. So remember, like I said before, these are always going to be subtraction problems when it comes to Pythagorean theorem, because we are never going to need the hypotenuse to be solved for in order to run an area or volume. So our base is going to be equal to 16. Alright, now I can find an area, because now I have the two things I need. So big B is going to be 1/2 base times height, again, it's the base shape of the triangle. So 1/2 is 16.5, and then that height is 28, so flip it over. So big B is going to be equal to 231. The only thing I need is to go from area to volume is the height. So I need that big B and multiply by the height of my big B. Well, connecting my two together, if I'm looking at upper corner and upper corner, the segment connecting those two to each other is that 31. So that 31 is the height of my prism, and that would give me an overall volume of 7,161 millimeters. So just keep in mind that you are going to have two heights whenever you're running these. A height of the just base shape and the height of the prism. That's very different. So I used one of my heights was 28. I used that 28 right here when I did the area from the triangle. My other height was 31, and I used that when I did the volume. So just notice that those heights are different. All right. For cylinders. The volume formula of a cylinder is 5 times radius squared times height. A cylinder is actually just a piece of paper that you can take your notes right now and roll it up, and that's going to be a cylinder. So it really is just a rectangle rolled together. So if I'm looking at number 10, my base shape is that circle. This is my base shape. And I have two of them. They're the only things that aren't rectangles. That's why I know they're my base shape. And so it starts to do the volume. You're just going to take pi times our radius. Well, I don't have radius. I have a diameter. Remember to find your radius. You take the diameter and put it in half. So that's going to be 5.5. 5.5 squared times your height. So my volume there use the pi cube, you might use 2.14. That might change your answer a little bit with our rounding. So just keep that in mind. We will keep that in mind when we do this as well. Alright, so it's application. So let's look at number 11. A cylinder with a 2 centimeter diameter is drilled through the triangular prism. Shown on the left, find the volume of the prism. So if it's drilled through, it's no longer in there. So at the end of this, I'm going to want to subtract my two values from each other because it's no longer in there. So the first thing I want you to do is I want you to find the volume of the cylinder. The volume of your cylinder is pi radius squared times height. So just keep in mind that you're going to need to find your radius because you have the diameter. So go ahead and pause and do that and then answer it when you are asked to in the video. Okay, so for our volume of the cylinder, you should have put on 44 meters. Now for that triangle, so if we locate our base shape, here's the triangle, and then the triangle down the bottom, so this is the triangular prism. Notice, really important to me, there's a right angle. You might not be able to see it, might be really small here. You have a right angle. So I want you to find the volume of that triangular prism. So remember, first you find big B, 1/2 base times height. That's the area of your triangle. Then you're going to take that and you're going to use the volume, which is big B times H. So go ahead and pause the video and do that on your own and find the volume of the triangular prism. The volume, guys, not the area. Alright, so for the area, if we were to just fill that in, 1/2 base, which is 5, times height, which is 5, because those are my two perpendicular segments. For that, you're going to get 12.5. So again, taking that, finding volume, I take 12.5, multiply it by the overall height, which is 14. So we should get a volume of 175 centimeters. So lastly, I'm subtracting these two to find the overall volume. Again, it's drilled through. And that should give me 131 centimeters. Okay. Let's look at another one. A diagram of Eric's pool is shown on the left. He plans to fill his pool to a depth of 4 feet with a garden hose that has an 80 feet cubed per hour flow rate. How many hours will it take to fill the pool? So basically, I need to find the volume, but what's changing is I'm only filling my water level to 4 feet instead of the 4.5 feet that they gave me for the pool. So I'm not filling all the way up. So my height is actually going to be 4 instead of that 4.5. So go ahead and find the volume of your cylinder. Remember, it's pi radius squared times height. So keep in mind, you need your radius. Keep in mind that your height is only going to be 4. Go ahead and answer that when you are asked to. So for our volume of our cylinder, we should get 2,290.22 cubed. I did pi. I did 13.5 squared, and then I did times squared. So I just need to figure out how long it's going to take for it to fill. So I'm looking at that and I say, okay, well, that's my volume and it's going to fill 80 feet per hour. So to figure out the fill, I'm going to take that volume and divide it by how much it pulls in at a time. So dividing it by 80, so we get approximately 28.63 hours. All right, make sure you bring any questions you may have to class tomorrow.